Okay, hello there. Here's a bit of a video on geometric series, which you might have seen this formula around before. A is our starting term, R is our common ratio, N is the number of terms we're summing up. So you might have seen this formula around before but wondered where did it come from? How did they get that one? It's not actually as hard as you think. So let's derive that. Let's see where we get that from. Now, you would be aware from your series work and your sequence work that a series, Sn, is really just summing up all of the previous terms. So the first term would be A, the second term would be A times R, multiplied by the ratio once. The next term, AR squared, another multiplication of the ratio, etc., etc. We come to this one here, let's talk about that. AR to the n minus 1. Now remember in some of the previous videos that the number of jumps that you're making is the R value that you need. So if you're making 3 jumps from T1 to T4, you're going to multiply by R cubed. Okay, so the number of jumps, which is 1 less than the term number. So if I want to sum n terms, then here I want n minus 1. And you might think, but hang on, aren't you missing one of them? No, we're not, because isn't this one really AR to the 0? So look, we've still got n terms in there, but because the first one started at R to the power of 0, the last one must finish at R to the power of n minus 1. Hopefully that works for you. If it doesn't, do a bit of work around that, because that's a pretty key concept to understand why. So I wrote this out, and as I say, sum is going to be summing up each of these terms and however many fit in here. Now then what I've done is I've multiplied that same formula by R. So this becomes R times S of n. This one becomes that. See how I've updated. That one there, actually I've made a mistake. That one there is going to become that. Oh, there we go. Good pick up there. So the last one, when I multiply by R, is going to become this here. Let's check that. Let's see what's going on. So if I take that, AR to the n minus 1, and multiply it by R, isn't that R to the power of 1? And aren't these the same base? So couldn't I write AR to the power of n minus 1, add 1, same base, add the powers, cancels out, AR to the n, oh, there we go, AR to the n right there. And the one before that would be AR n minus 1. On this line it would have been AR n minus 2, multiplied by R, we get that. And the same thing would happen all the way along there. So that's the idea that's happening at the end here. So now what am I going to do? Well, with these two here, I'm going to subtract one away from the other. So if I do this one, this whole line, subtract this whole line, what do I get? I get Sn minus R lots of Sn over here. Now on this right hand side, I've got the A, I'll put that down. Now wouldn't I have then add this, but minus this one? So can you see how these two terms, because I'm subtracting away, that'll be a plus, that'll be a minus, gone. These two terms, they'll cancel each other out as well. The next two terms, the same. Okay? This one and this one will cancel each other out. I'll just be left with this guy. That's the only thing I've got left. So I'll have minus, remember, AR to the n minus 1. Well, that's looked pretty simple now. Let's work with this part. On the left-hand side, I'm going to take a common factor of S to the n out front. So why do I end up with 1 minus R? And on this side, I'll take a common factor of A out front. Won't I be left with 1 minus R to the n? Oh, I made a mistake there, didn't I? That one will cancel out. This one here is what I get left with. There we go, tidy that up. Now, that's pretty close to what we've got, isn't it? If I divide this side by 1 minus R, I've got to divide this side by 1 minus R. That's going to cancel. So s to the n is equal to a brackets 1 minus r to the n over 1 minus r. Put that in a big box. There you go. There is your sum formula for geometric series. You don't need to believe the formula now. You've seen it work. And it wasn't that hard anyway. Hope this one helped. Good on you guys. Keep working hard with your maths. I'll catch you next time.